In this video, I'll be going over how you can containerize your FastAPI application. Containerizing an application is a great way to make your application portable, consistent, and easy to deploy and share. So let's get started. So just a preview, I want to show you guys the functioning containerized application. So here I have Docker Desktop, and I have the FastAPI auth hosting two containers. One is the actual app, which is going to be the auth app, because I'll be utilizing the FastAPI application from my FastAPI authentication and authorization series. I recommend checking it out, but you are free to use any application as your base. So for my application, a user will be able to sign up, log in, and utilize a protected route using a JWT token on a port exposed through Docker, which in this case is port 80. Now, to use the authorization application, we need to store information regarding the user. So I also have a Postgres instance that is connected to my application, and that's why I have this second container, which is going to be hosting Postgres, the latest version of Postgres, running on 5.4.3.2, and these two will be able to communicate with each other, no issue. So let me swing over to Postman so you guys can see my application running as expected as a container. So here I am in Postman, and I have three routes, right? I have the sign up route, the login route, and I have the protected route. So when I sign up, it's expecting first name, last name, email, and password. And as you can see, I am trying to connect to port 80, which is where my application is exposed locally, right? So it's localhost because it's still running on my local machine, but it's being exposed on port 80. And then it's the actual route of sign up from my app internally. Now, if I press sign up, you can see, boom, it's connected, it's created, get a 201 response, and this is coming from my application that's being ran in that auth container. Now, if I go to the login route and I utilize the same email and password that I just signed up with, and I press login, it returns me a token, right? And I have this test script, which essentially assigns a environment variable in Postman of JWT to the value of the token. And I can see here I forgot to change the name. It's actually token. So let me send that again. Same body, but when I press login, now this token value is going to be stored in a JWT environment variable. So if I go over to protected, which is the protected route from my auth application, and I hover over JWT here, you can see that the current value is the JWT token that was returned from login. And if I press send for this route, you can see that it's just returning the information about the specific user. So that is the full flow, and this is all being ran from my containerized application. So this is what you should expect to see if you're using my application as the base. But if you're using your application as a base, you should be able to communicate with your containerized application by the end of this video. Alright, so here I am in Visual Studio Code, and we can begin the process of containerizing our application. The first thing that I'm going to need is a Requirements.txt. This is going to be the dependencies that this FastAPI application needs to actually run properly. So currently I'm already activated in my virtual environment. If you guys utilized a virtual environment, then go ahead and activate that, because when retrieving the requirements or dependencies for this application, if you don't specify or if you don't activate your virtual environment, it's going to grab all the dependencies that are locally on your machine, and we don't want that. We want to get the dependencies that we specifically use for our application, and I know I have that in my virtual environment. Now, to get that information from my virtual environment, or if you have it locally and you don't mind it being locally, to get those dependencies, all you have to do is use pip, and depending on the version of pip that you have, it can either be just pip or it can be pip3. In my case, it's pip3, and I'm going to do freeze, and this is going to grab the dependencies, right? But what I want to do is I want to grab those dependencies and put it into a file. So I'm going to use this greater than sign and specify the name of the file that I want to create with the list of dependencies that I utilize. So if I do Requirements.txt and press enter here, you can see that it creates a file here. And if I enter this file, you can see that it has all the dependencies that are in my virtual environment that I installed to use with my FastAPI application, my auth application. And this is going to be important when containerizing the application, because we're going to need to grab this file, put it into our container, install those dependencies so that the application runs as expected inside of the Docker container. So the next step I got to do is create a Docker file. And a Docker file is simply just a set of instructions that Docker utilizes to create an image so that we can run a container based on the instructions that we set in the Docker file, based on the image, right? So I already have the Docker file created, so I'm going to go step by step on what each line means, just to save some time. So the first line, we're essentially telling the Docker file that we want to grab the official Python runtime as a parent image, right? This is going to be the base image, and we're grabbing Python version 3.12 Slim, right? We're going to essentially grab a compressed version of the Python runtime. Now, you can specify whatever version that you want, but in my case, 3.12 works well for my application. You can also specify this Python to be the latest version of Python, but oftentimes I make sure to use a specific version, just in case the latest version of Python doesn't work well with my application. So I recommend just going through whatever version or whatever specific version fits your application and utilizing that instead of just always using the latest version of Python. Or you can keep track of always getting something right before the latest, just to make sure that the latest version is hashed out, everything is working as expected, and then you can upgrade to whatever latest version of Python is being utilized. Now the second line is the work_dir command, which is setting the working directory in the container. This is going to be the directory which our commands are going to take place, right? If we don't specify a working directory, everything is going to take place in the root directory. Personally, I don't like to do everything in the root directory, so this is why I set up a working directory which is going to house everything related to our app, and that's why I called it /app. And because we set the working directory as /app, this next line is the copy command, which is going to copy from our current directory here to our internal container, right? So it's going to copy the requirements.txt, which is here, and copy it over into our container, which is going to be important because remember, requirements.txt has all of the dependencies that is needed to run our application smoothly. So by copying this over, and essentially it's going to copy it over to the app directory, we now have access to all the dependencies that are needed to run the application. And the next line is the run command, which is going to run a command for us, and this command is doing a pip install, which is going to install all the dependencies in our requirements.txt file. And after installing all the dependencies that we'll need to run the application, we can go ahead and copy all of the additional files into our working directory. So this is why this dot, which is going to mean the current directory, is going to copy it over into our working directory. So that's why there's two dots here, copying it from our current directory into the current directory in the working directory in our Docker container. And then afterwards is essentially saying, okay, we want to expose this container on a specific port, and in this case I'm specifying port 80. Remember that when I did the Postman commands, right, of login, sign up, the protected route, all of it was done from localhost port 80. So this expose 80 is essentially saying make this port 80 available to the world outside this container, right? I'm going to be able to do HTTP requests only to the exposed port, which is 80. This is the only entryway into our application from the outside world. And this last line is essentially saying what command do we want to run when we run this container officially, right? So we got to put it essentially in a list, right? We got to separate each command separately. You can't put it all together. You got to put it separately. And I'm going to break down what each one is, right? There's UVcorn. UVcorn is a high-performance ASGI server. ASGI meaning asynchronous server gateway interface. As the name suggests, both acts as a bridge between web servers and our Python web application, which is FastAPI. Then there's the main::app, which main being the file, right? The main.py that we have, which is right here. And the app being the object created inside of the main.py. Remember the line of, and when we go inside, app equal FastAPI, right? That's essentially what these two words mean in the Docker file. So right here, and then we have the host, right? The -- host, and it's specifying 0.0.0.0. This is just specifying that we'll listen to all the IPs on port 80, right? And that's why we specify the port here as 80. So essentially, this FastAPI application is going to be running on port 80, and it's going to be accepting requests from all IPs. So this is going to be the command that runs when the container is constructed, and that's what's going to allow us to accept requests from the outside. So now that we have the instructions, right, to build our image, right, we can go ahead and do docker build -t, meaning tag. We can give it a name, and I'm just going to call it FastAPI-auth, and it has to know what to use to actually build it. It's going to look for a Docker file, and where can it look for a Docker file? Well, it can look in the current directory, so I can specify the dot, meaning the current directory, which is where this Docker file is going to be placed. So now that we created our Docker file, we set the instructions for how we want this image to be built. We actually have to build the Docker image. So to do that, you could do docker build -t, and we're going to give it a name, right? This -t essentially gives it a tag, and I'm going to give it the name of FastAPI-auth, and it has to know where are the instructions being held. Where's this Docker file being held to construct this Docker image? Well, it's being held in our current directory, so I can use dot. If it's somewhere else, then you can specify the specific directory, but since I know it's right here in this current directory, I can just use dot, press enter, and you can see that's going to be running each specific step by step. And if it's been built before, it's going to try to use cache or use a cache just to save time. But yeah, it's built. So to run the container, and let me just clear this out, and let me try to make this a little bit bigger. To run the image to create a container, we can do docker run -d, which means detached, meaning it's not going to be running in our command line. It's going to be running in the background. Then I use -p, and I'm going to specify the ports that we're going to expose to communicate with our container, which is also exposed internally on port 80. So I'm going to say 80 from our machine to the port of 80 internally in the container, right? Because that's the only port that's exposed, or that I exposed when creating the Docker file, right? Which you see right here. So from our port 80, we're going to route anything that hits port 80 to port 80 in the container, which is exposed. And then finally, you guys specify the name of the image that we want to run. So FastAPI-auth, which is what we just built. Press enter, and I'm already running a port on 80. So let me go ahead and close. So as you can see here, it's already running on port 80. So it's saying, you can't run multiple things on that. So let me go ahead and stop that. And you can see here, it's tried to start it up. It's broken right now, but it's created. You can see that it's getting the latest version of FastAPI-auth. It's just not running because of that issue, but I can go ahead and press start again, and it's going to attempt to run it. Now there are going to be issues because of the fact that it is going to require a connection to a database, which it doesn't have, and also it's dependent on a .env. So I'm going to go ahead and move on to the next step, which is going to be Docker Compose. So if your FastAPI application depends on other services, like a database, for example, like mine's, you might want to use a Docker Compose, right? So I already created the Docker Compose. It's a YAML file, and if you spell it out correctly, you can see that there's like a little pink well here if you're using Visual Studio Code. So this Docker Compose.yaml is just going to allow us to set instructions on how we want everything to intertwine, right? Because like I said, I have a FastAPI-auth application that is dependent on a database. So what I want to do is I want to set a list of instructions so that I can start up the database instance or the database or Postgres container first, and then build up my FastAPI application afterwards so that it can all intertwine. And we're going to be leveraging a virtual network, right? So in a Docker Compose, it allows us to create a virtual network that allows for containers defined in our compose file, which is this file, to communicate with each other. So it provides an isolated area or an isolated network for our containers to communicate with each other. And it provides a sense of security, right? Because it leaves out everything outside, right? It's its own network isolated from everything else, and enables them to interact seamlessly while remaining separate from other networks or other containers on the machine. So To do that, and I'm going to go through each line like I did before, but the network, I specified the network here. You know, you're going to have to use a key value type of approach, and the thing with YAMLs is that everything is structured with some type of indentation, but we use Python. We should know about this already. Like with the indentions, it's very specific, but there's this network section, right? And we define an app-network, right? And this is going to be our own virtual network that is going to allow for our FastAPI application to connect with our database. And the database, and let me start off here. I have a key of DB, and you can provide a colon and specify the image that we want to utilize to eventually construct a container, right? And in this case, I'm using the latest version of Postgres. If you have a specific version that you want to use, or if you're using another type of database, you can specify that here, but the image that I'm going to be utilizing is Postgres, or the latest version of Postgres. And I'm specifying a container name of auth-db. This can be whatever name that you want, but it just makes sense for me to use auth-db. Then I'm specifying the environment variables, right? So I'm specifying the Postgres user to be user, and a Postgres password to be password. Obviously, you don't want to always inject it here. You want to use a .env, which I'll show you how to do, you know, for the FastAPI application. But this is how you would do it without a .env, right? You just inject it in its own environment section, right? And you gotta make sure that it's indented properly as well. So the name has to be on its own line, and then you have to indent the additional properties, and the properties within another property or nested properties has to have an indentation as well. It's just how YAMLs are constructed. And then here we specify the ports of 5432, and then the actual network that we're going to be utilizing, right? So the virtual network, which we created down here of app-network, we're specifying that this Postgres instance is going to be within this network of app-network. So that's the first part of just the database service. And then the second part is the actual FastAPI application that we created, or that I have, which is the auth application, right? This is going to be given the name of app, and I'm going to use the key of build. And what does this mean? Well, build is going to look for a Docker file, and you can specify the directory of where this Docker file is going to be. Like I said, I use dot here to specify that it's going to be in the current directory, because the Docker compose and the Docker file is in the same directory. So it's going to look for that Docker file, it's going to build it, and then what it's going to do is I can specify the ports here, like I did with the command. Remember, I did -p for the ports, but here I can specify the ports manually, and then specify the network that I want to run it on, the virtual network that we defined below, and the network that the database is a part of. So they're both going to be on the same network, isolated from everywhere else. Then there's this key of depends on, right? We want to make sure that before we start this FastAPI application, we need our Postgres container to be running first before running our FastAPI application. Because if it doesn't start first, then it's not going to run properly. So it depends on DB, which is just the key name of our Postgres instance, or our Postgres container, right? And you know, every service here has a specific name. So for the FastAPI application, the key is app, and for the Postgres instance, it's going to be DB. And this FastAPI application depends on DB. DB has to be running and functional before we start up this FastAPI application. And then I specify the environment variables, and instead of using environment and injecting it this way, I'm using a .env, right? So I have a .env in the same directory, and essentially going to inject that .env, and it's going to allow for my application to extract those values from a .env instead of having to just directly place the name and value like this. You can just use the .env and specify the .env file, right? Using the env_file key. So I know it's a lot. I don't expect you guys to memorize the whole file, so I'm going to put this file, or the next couple files, the Dockerfile, the Requirements.txt, and the Docker Compose, inside of my GitHub that houses the authentication application, and you guys can also check it out. So now we can go ahead and build these containers based on the Docker Compose file. So to do that, you can do Docker Compose up-d, meaning detached, press enter, and you can see that it's going to run those two applications. Now with the current Docker Compose, it will build based on the Docker file that's in the current directory, right? We use the dot here, and it will look for a Docker file, and it will build a container based on that. But if you want to specify a specific image, right, you already have it being housed on your local machine, or maybe it's in the Docker registry, you can specify the name of the image. So in our case, we built a image by the name of FastAPI-auth previously, so we can go ahead and use that. And if I do docker compose up-d, you can see that it's going to attempt to recreate it. It's going to attempt to start it, and you can see that it started. So that's another way that you can go ahead and build your containers to run in a Docker Compose. So you can either try to look for the Docker file, or you can already have a image in mind, like just like what we did with Postgres, right? This already has an official image that we're just grabbing from, or maybe you already built one previously and you just want to specify the image. You can do that here. And here I am in Docker Desktop, and you can see it's running as expected. It started about 30 seconds ago. It's incrementing every 5 seconds, but we have the app and we have the authDB. Now, one thing to keep in mind when attempting to connect to your Postgres instance that is being ran using Docker Compose on a virtual network is that it's not on localhost anymore. It's its own instance on a virtual network. Now, to get access to that, we're going to have to change the host from localhost to the host of this virtual network. And to do that, it's pretty simple. Now, if you're using a .env like I am, which is housing, secrets, which in this case is not so secret anymore. But here I have the host. Like usually for the host, it's localhost, right? You probably have it as localhost, right? But because it's on a virtual network, you have to specify the host as DB, or whatever name that you define the name of this service to be. And this is going to inject where it is or what network it's on directly to the host here. So just specify the host name to be the name of the service that's housing your Postgres instance. So you're probably facing issues on like, why is this not connecting? Well, it's because you're using the wrong network, right? You have to specify or change the name from localhost to the name of the service that's housing your Postgres instance, and you should be good to go on that end. So here I am back in Postman. If I go to sign up and I do send on the sign up on port 80, remember that it's exposed on port 80, and I do sign up, I can see that is 201 created as expected. If I log in, and I gotta make some changes here. The email is chio@gmail.com. Press send. I got the token, and remember with the test script that I have, it's assigning the token to a variable of JWT, and if I press send here, I'm able to get my information, right? Because this is expected from a protected route, because I'm grabbing my information based on the value in the JWT, right? So that is how you can Dockerize your FastAPI application. It's useful when you want to keep things consistent and you want to be able to share it. You can have it created as an image. You can share that image. All you got to do is place it into a Docker registry, and I'll show you that really quick. So to get access to your Docker registry, first you have to do Docker login, and Docker will start the process of bringing you to the Docker website for you to log in. I'm already logged in, so I'm not going to do that again. But what you could do is do Docker tag the name of the image, which is the image that is built locally on your machine. So before we built a FastAPI-auth, but you can use whatever name that you used to build your image before is what you're going to have to use here. We're going to have to tag that to what's going to be housed in your Docker registry. So you have to specify your Docker Hub username, which in my case is tech with geo / and I want to provide it a image name. In this case, I'm going to keep it the same, so FastAPI-auth. Press enter, and now it's tagged. And now all I got to do is Docker push, and I can do tech with geo, which is just going to be the Docker Hub username again, and the image name, right? So FastAPI-auth, and it's going to be pushing all the latest changes to your Docker registry. So now with the port closed out, let me do Docker run -d -p, specify the port, so 80:80. Let me give it a name to make it less confusing, and I'm going to call it from the hub, and I'm going to do tech with geo / FastAPI-auth, which is just the name of what we pushed it as. So if I press enter, you should see the hash that it contains, or that that it was assigned. And I don't expect it to work because this is not gonna be able to connect to a Postgres DB. But what I could do is I can grab this name here and I can just specify here, right? It doesn't have to be my local FastAPI-auth. It can just be directly from the registry, and this should work. But let me go and confirm that it doesn't work in Docker Desktop just to show you guys. So from here you can see that from the hub is exited, right? It doesn't work. If I go inside, you can see that it just breaks. It's not going to be able to because there's no database to connect to. So when I'm trying to create the engine here, you can see that there's a problem, right? SQL Alchemy is just not going to be able to do what it has to without a database. So let me go back and show you guys that it will still work with Docker Compose, but using the image from the registry. So if I do Docker Compose up -d, you can see that it's being recreated again. It's starting up, and now we have two functioning applications. One was ran 8 seconds ago, the other was ran 14 seconds ago. So you can see that it waited for the DB to run first, because obviously you can see there's a difference in time between the DB and the actual FastAPI application, because the application depends on the DB. So it has to wait for the DB to run before running the application, and it works as expected. So if I go inside, you'll see that it's running on port 80, is accepting all IPs, and we're good to go. So that is how you can Dockerize your application. That's how you can put it into your registry, and that's how you can run your application using the image that is on your registry. So just a full process. And this is how you can use the Docker Compose to make your application communicate with other services using a very structured manner of a Docker Compose.